we know of 4 different fundamental forces in physics. That's the electromagnetic force that most of you have probably heard of. Then we have the strong and weak nuclear force, and we have gravity. And the problem is that 3 of those forces, the electromagnetic and the 2 nuclear forces, have quantum properties. So we have some particles like electrons and quarks and gluons, stuff like this. And we know that they do funny things, like they obey the uncertainty principle, they can be in 2 places at the same time, that kind of weird stuff. And then there's gravity, which is described by Einstein's theory of general relativity. And that theory doesn't know anything about quantum properties. And this brings up the question, if I have a particle like an electron that can be in 2 places at the same time, and it has a mass, and that mass generates a gravitational pull, where does the gravitational pull go? You'd expect that to also go to 2 places at the same time. But Einstein's theory can't make that work, because it doesn't know anything about quantum properties. So this leaves us in this weird position where we just don't know what the gravitational pull of an electron is. So it's a really simple question, like what's going on with the gravitational field of this electron, and we don't know. And if you ask like more technically, what's the matter? It's just that those 2 theories, the quantum field theories that we use to describe particles, like the electron and a couple of other particles, Einstein's theory of general relativity, they're just mathematically incompatible. If we just put them together, it doesn't work. But nature knows how it works. So there's got to be a solution to this. And we don't know what it is. There have been many people who've tried to solve this problem. What we need is a theory of quantum gravity, so a theory that gives properties to gravity, at least that's the way that it's normally put, but more generally we need some way to resolve this discrepancy between the 2 theories. And the probably best known approach to this is string theory, that most of you will have heard of. There are other ideas like loop quantum gravity, and then there are less well-known ones like maybe asymptotically safe gravity and stuff like this. But so far, we don't know if any of those is correct or how we can even test them. And yes, I think it's a really big problem. Now, when it comes to my personal opinion on what to do, as I just said, like, people have worked on this problem for a long time. It's been known since the 1930s or something, so it's definitely not a new thing. And there are lots of smart people have spent their whole life trying to fix something that they think is wrong with gravity. And I have a lot of respect for all those people, and if they couldn't make it work, I'm pretty sure I can't make it work either. So this is why I think it's a better strategy to try and figure out if not there's something wrong with the quantum side of things, that the problems may be caused by us not understanding what quantization means in the first place. I generally think it's not good to put our bets on one thing. So I'm really supportive of spending some time on modified gravity and different approaches to that kind of thing. Spending some time on the idea of trying to replace gravity or explain it as something emergent or induced gravity. This is a similar but related idea. Or maybe just saying maybe the fault is with the quantum side of things, which is what I personally work on.